Ever get that feeling, like you're chatting with a bot and it's going okay, it seems like a decent conversation.
Hmm.
But then it's like all of a sudden it just goes off the rails. It loses the plot or starts saying stuff that's just, well, kind of weird.
Yeah, I know exactly what you mean.
If you're anything like me, you want to get under the hood of these things, really understand what makes them tick.
Absolutely.
And especially, why do they sometimes feel so short-sighted? Like they can answer a simple question, but then they just totally miss the bigger picture of the conversation.
Right, it's a huge challenge, right, to make these AI conversations, especially over multiple turns, to actually be good.
Yeah.
It's not just about giving the right answer in the moment.
Hmm.
It's about how that answer sets up the whole rest of the interaction.
Exactly. And it's frustrating because you can see the potential, right? Like they can give you a good answer, but then boom, a few turns later, it's like they've forgotten everything.
Yeah, you might get a chatbot that gives you a perfectly fine answer in the beginning, but then without that kind of awareness of where the conversation is going, it can lead to these really unproductive or even harmful outcomes down the line.
It's like they're so focused on winning that one little exchange that they lose track of the whole game.
Plays dicely.
Well, today we're diving deep into some really cool research that's trying to crack this nut.
Oh, this is going to be good.
We're going to explore a new approach to making these AI conversations flow more smoothly and stay on track.
I'm all ears.
It's called SCOPE, which stands for, get this, Semantic Space Conversation Planning with Improved Efficiency.
Catchy.
It comes from some brilliant minds at the National University of Singapore and A-Star in Singapore.
Okay.
Zilian Chen, Xinyuan Yu, Chuan Shengfu, and Brian Qian Xiang Lo. These are the researchers behind it.
Impressive.
And their work is all about making this whole conversation planning thing way faster and more efficient.
And that's important, right?
Yeah.
Because who wants to wait around for ages for a chatbot to figure out what to say?
Exactly. Ain't nobody got time for that.
So we're talking about speed, but also safety.
You got it.
Because I can imagine a scenario where you might get stuck in this loop with a chatbot that just keeps repeating the same kind of safe but ultimately boring responses.
Right. It's got to be engaging too, right? Like you want it to feel like a real conversation, not just a robot spitting out canned responses.
For sure.
So our mission today is to understand this whole concept of conversation planning for the big language models that power these chatbots.
The LLMs, right?
Yep, the LLMs.
The brains of the operation.
And we're going to see how SCOPE aims to make these conversations more engaging, safer, and crucially, much faster than what's been possible before.
Okay, I'm ready to dive in.
So let's start by tackling this issue of chatbots being too focused on the immediate response, that short-sightedness we were talking about earlier.
Yeah, what exactly goes wrong there?
Well, as the researchers point out, these approaches tend to pick a response that seems good in the moment.
Good meaning.
Yeah, good based on some immediate reward.
Right, so it could be something simple like the user saying thanks or that's helpful.
Exactly. Or it could be that the chatbot's answer directly addressed the user's last question.
Uh-huh.
But here's the catch, and the paper gives a really interesting example of this in Appendix A-1.
Hit me with it.
They describe how two different chatbot responses might seem equally positive at first.
Okay, so far so good.
But, and this is where it gets interesting, one of those seemingly good responses might, several turns later, lead the conversation down a path that's harmful or just completely unproductive.
Oh, I see.
They give an example about vapes, which is pretty illustrative, right? Like a seemingly innocent initial question about vapes could, without proper planning, snowball into discussions about way riskier topics.
Right, it's like that slippery slope where one seemingly harmless step can lead to something much more serious.
Exactly. So even if both initial responses get a similar thumbs up in the moment, the long-term results can be totally different.
Especially when it comes to the safety of the conversation.
Right, and that's the big problem. Picking the option that looks good right now doesn't guarantee a positive conversation down the line.
So you're saying we need to look beyond that immediate win and think about the overall quality of the whole conversation.
You got it.
What they call the cumulative reward.
Exactly, cumulative reward.
And the researchers mentioned another potential way to tackle this, right?
Yeah.
Like trying to train the LLM itself to implicitly aim for those better long-term outcomes.
Right. In theory, that sounds great, but as the paper points out, it's incredibly resource intensive.
Wow.
You'd need tons of human feedback, basically people rating entire conversations and saying which ones are better.
Right, like a whole team of people just listening to chatbot conversations and judging them.
Pretty much. And then you'd have to repeatedly fine-tune the model based on that feedback.
Okay, I can see how that would be a logistical nightmare, especially if you're dealing with a large language model.
Yeah, and think about it from the perspective of someone who's actually building and deploying these LLMs. They might have different use cases, different goals for their chatbots, and you'd have to go through this expensive retraining process every single time you wanted to prioritize a different reward.
Like, if you wanted to switch from focusing on engagement to making sure the conversations stay safe, you'd have to retrain the whole thing.
Exactly. It's just not a practical solution for a lot of real-world applications.
So what's the alternative?
Well, the researchers behind Scope, they're taking a different route.
Okay, I'm intrigued.
They're not trying to fundamentally retrain the LLM.
Uh-huh.
Instead, they're focused on strategies that can be used while the conversation is happening.
So real-time decision-making.
Exactly. How can we be smarter about choosing the best response from the LLM's suggestions in the moment?
So that sounds more manageable.
And there's been this growing trend to use LLMs themselves, along with these search algorithms that involve simulating future scenarios, like Monte Carlo tree search or MCTS, for planning in language tasks.
MCTS, that rings a bell.
The idea is to get the LLM to imagine how the conversation might play out based on different initial responses.
Right, like a choose-your-own-adventure for chatbot.
Exactly, and then see which one is most likely to lead to a good outcome.
But I imagine there's a catch.
Oh, there's always a catch, right?
What's the bottleneck here?
Well, as the paper highlights, the major sticking point is the sheer cost of running all those simulations, both in terms of time and computing power.
Uh-huh, that makes sense.
To get a decent idea of what might happen down the line, these traditional simulation-based algorithms often need to spend hundreds, even thousands of seconds planning each turn.
Whoa, that's a long time for a chatbot to be thinking.
It is, especially when you consider that users expect a reply almost instantly.
Right, you don't want to be sitting there twiddling your thumbs while the chatbot's off in La La Land trying to figure out what to say.
Exactly. It's an eternity in a conversation.
So even if these simulation methods could theoretically find a really good long-term strategy, they're just not practical for real-time chats because they can't do enough of that thinking ahead within a reasonable time frame.
Right, and the paper also mentions that all those queries to the LLM for simulations can get really expensive, especially if you're using an external LLM service.
So you're basically paying through the nose for all that thinking time.
Pretty much.
So how does Scope get around this?
Well, the key innovation here is that it moves the conversation planning into what they call semantic space.
Semantic space. Okay, now we're getting into the good stuff.
Instead of working directly with the words of the conversation during planning, they use these dense semantic representations.
So it's not about the literal words themselves, but rather the underlying meaning and context of what's being said.
You got it.
Okay, so how do they represent meaning as a space?
Think of it like this. Instead of focusing on the specific words being used, the AI tries to understand the underlying meaning and context of the conversation.
Okay, that makes sense.
And then it represents that meaning as a point in this abstract meaning space.
Ah, so each point in this space represents a different meaning or concept.
Exactly.
And have these kinds of dense representations been shown to be effective?
Oh, yeah, absolutely. They've been shown to be really good at capturing the meaning of natural language.
Okay, so we're not just talking about some theoretical concept here.
Nope, this is based on solid research.
So how does Scope use this semantic space for conversation planning?
Well, the researchers realized that a conversation can be thought of as a sequence of transitions, like a path through this semantic space over multiple turns.
So instead of having the LLM simulate future conversations word by word, Scope tries to predict how the conversation will move through this meaning space.
Exactly. It's like having a map of the conversation landscape.
Oh, I like that analogy.
And the cool thing is, Scope also learns what kind of rewards are typically associated with different areas in this space.
Rewards like what?
Things like engagement or safety, the same kinds of things we were talking about earlier.
So it's not just about predicting the paths of the conversation. It's also about figuring out which paths lead to more desirable outcomes.
Precisely. It's like having a map that also tells you which areas are more likely to have good restaurants or scenic views.
That's a great way to put it.
So instead of having to explore every single possible conversational path in detail, which is what those traditional simulation methods do,
With all those costly LLM queries.
yeah, Scope can navigate this meaning map much more efficiently.
So it can do its look ahead, its planning, much faster without constantly needing to go back to the LLM for more simulations.
Exactly. It's almost like Scope uses the LLM to generate some initial response options, and then it takes over and figures out the best one by planning in this meaning space.
That's clever.
Now, during an initial learning phase, Scope looks at existing conversation data to learn two main things.
Okay, what are those?
First, a transition model that predicts how conversations tend to move from one point to another in the semantic space.
So it's basically learning the common patterns of conversation flow in this meaning space.
Exactly. And second, a reward model that estimates how desirable it is to be in different parts of that space.
Ah, so it's learning which areas of the meaning space are associated with good outcomes and which ones are associated with bad outcomes.
You got it.
And then, when you're actually chatting with the AI, Scope takes the current conversation, the potential responses from the LLM, maps them into this semantic space, and then uses those learned models to do its planning,
Right. It's doing a kind of Monte Carlo tree search, but entirely within this meaning space.
which is the key difference, right?
Absolutely. By planning in the semantic space, Scope can explore a much wider range of potential conversational paths within the same amount of planning time.
Because querying its learned transition and reward models is way faster than making repeated calls to a full-fledged LLM for simulations.
Exactly. So what does all of this mean in terms of actual results?
Well, I'm eager to hear.
First, it really highlights that problem with being myopic, just focusing on those immediate good feelings can lead to some not so great outcomes down the line.
Right, like conversations becoming harmful even if the first few turns seem perfectly fine.
Exactly. And remember that example in Appendix A, Plot 1 about initial responses getting similar positive feedback but leading to very different levels of harmfulness later.
Yeah, that was a good illustration of the problem.
And Scope's whole approach is designed to address that directly.
Makes sense.
The second big takeaway is this idea of Scope's semantic shift.
Right, moving the conversation planning into that meaning space, using those dense language representations.
And that allows it to plan much faster without constantly needing to ask the LLM for simulations.
Which saves a ton of time and resources.
Exactly. And Figure 1 in the paper does a great job of illustrating how this learning and runtime process works.
I'll have to check that out.
And it's not just making up these transitions and rewards. The third key takeaway is that Scope actually learns from real data.
Okay, so it's not just some theoretical model. It's based on actual conversations.
You got it. It trains this transition model by looking at lots of examples of past conversations.
So it's learning how conversations actually tend to flow in that meaning space.
And it also learns a reward model, basically what kinds of outcomes we want by studying those same examples.
So it's figuring out which conversational paths are more likely to lead to good outcomes and which ones are more likely to lead to bad outcomes.
Exactly. And the paper even goes into some of the technical details of how they do this in sections 4.2 and 6.4.
For the more technically inclined listeners.
But perhaps the most impressive result is the speed. The fourth key takeaway is Scope's remarkable speed and efficiency.
How much faster are we talking?
Well, the researchers state that it's 70 times faster than traditional simulation-based planning methods.
70 times. That's huge.
It is. That's a massive difference for anyone actually using these chatbots.
Yeah, I can imagine that would make a big difference in the user experience.
And they even break it down further, comparing it to standard MCTS, showing it's 92 times faster per simulation.
Wow, so what used to take almost a minute now happens in less than a second.
Exactly. That's the difference between a clunky waiting experience and a seamless, engaging one.
That's a game changer.
And this speed is what allows Scope to actually explore enough of the conversational possibilities within a practical time frame to make better decisions.
Right, it can actually do the necessary thinking ahead without causing a major delay in the conversation.
Now, the fifth key takeaway looks at the practical side, the real-world examples of reward functions they used to test Scope.
Okay, so they actually put this thing to the test.
Oh, yeah, they wanted to see how well it works in a real-world context.
What kind of reward functions did they use?
Well, one was trying to maximize how long people responded to the chatbot as a way to measure engagement.
So the longer people kept talking, the more engaging the conversation was considered to be.
Exactly, and Table 1 in the paper shows that conversations planned with Scope led to users asking more questions, which suggests they were more engaged.
Makes sense.
And the other really important reward function was minimizing harmful content.
Okay, so they're not just focused on making the conversations engaging, they also want to make sure they're safe.
Absolutely, and they used a tool called Llama Guard 2 to assess the safety of the conversations.
And did Scope do well on that front?
Oh yeah, figures 3A and 3B show that Scope achieved higher cumulative rewards, meaning longer, more engaging, and less harmful conversations compared to other methods.
That's really impressive.
And it's fascinating that you can prioritize different goals like that.
It is. It makes you think about the potential trade-offs, right? Like, what if you wanted to maximize humor in a conversation?
Oh, that's a good one.
Could that potentially lead to less safe conversations, and how would Scope handle that?
That's a great question, and it highlights the complexity of designing these reward functions.
It's not just about picking one thing to optimize. It's about finding the right balance between different goals.
Exactly.
Now, there was also this really cool detail in the paper that caught my eye.
Oh, tell me about it.
They actually created visualizations of the conversations in that semantic space.
Yeah, in figures 3C and third.
And you can see how Scope's path tends to move towards areas that have higher rewards, while the more short-sighted approaches kind of drift into less desirable areas.
It's like watching the conversations unfold in this abstract meaning landscape.
Exactly. It's a really cool way to visualize what's happening.
So to sum up, we've seen how Scope offers a significantly more efficient way for chatbots to plan their conversations, which can lead to more engagement and safety.
It's a really promising approach.
But this research also opens up some really interesting avenues for future exploration.
Like what?
Well, what about the potential for even more personalization?
Oh, I like where you're going with this.
Appendix A.6 and A.13 discuss the possibility of fine-tuning those transition models using data from individual users.
So instead of just learning general conversation patterns, the chatbot could learn your specific communication style and preferences.
Exactly. Imagine an AI that truly understands the nuances of conversation over time, tailored specifically for you.
That's a really compelling idea.
And it makes you think about other potential reward functions we could explore, right?
Absolutely. Like, what if we wanted to prioritize learning in a conversation, or creativity, or even just making the user laugh?
Exactly. There are so many possibilities.
And this research really unlocks a lot of exciting potential for building more intelligent and engaging conversational AI.
It does. And if you're interested in diving even deeper into the technical details, the researchers have made their code and experimental setup publicly available on GitHub.
Oh, that's awesome.
The link is in the abstract and the reproducibility section of the paper.
So for our listeners who really want to get their hands dirty,
Exactly. It's a fantastic resource for anyone wanting to explore this cutting-edge area further.
well, I'm definitely going to be checking that out. This has been a really fascinating deep dive.
It has, and it makes you wonder what the future holds for conversational AI.
The possibilities are endless.
They really are.
Until next time.
Stay curious.